a touch on organic chemistry, which is usually a 2 or 3 semester course. Organic chemistry is a branch of chemistry that deals with carbon compounds, carbon containing compounds. We have what we call functional groups that take part in a reaction, so they function in a reaction. The first functional group is an alcohol. An example is methanol or even ethanol. Ethanol will have 2 carbons and 6 hydrogens and 1 oxygen. But here what you're looking at here is methanol, which is CH3OH. The OH part is this part. The oxygen is red. There's a hydrogen here. That's a carbon. Hydrogen, hydrogen, hydrogen with the carbon in the middle. While beer, ethanol makes you happy, methanol kills eyesight. Very toxic. Methanol is toxic. The difference is just a carbon. So both of them are alcohols. Then you have amines. Example is methylamine, which is just CH3NH2. We talked about this before. Then you also have carboxylic acids. Carboxylic acids including acetic acid. Acetic acid will have a carbon with 3 hydrogens, and then you're going to have a double bonded oxygen and carbon linked together, and then you have another oxygen, and then you have a hydrogen. Remember, the oxygens are in red, hydrogens are in white, and the carbons are in gray. They are joined together by sticks or bonds. Acetic acid is the main ingredient or main chemical or compound in your vinegar. It's what gives the vinegar smell. There are other functional groups like alkenes, alkanes, alkynes, sulfides, thiols, ethers, anhydrides. There are other functional groups that have not been mentioned here, so it's important that I mention that you also have other functional groups in organic compounds that function in a given biological reaction or even a physical artificial reaction. So listed here is the common hydrocarbons. That's a methane, ethane. You'll see that eth, you have 2 carbons. Meth, you have 1 carbon. Not meth, the drug. Okay, the illegal drug. Prop simply means 3 carbons. So propane is the C3H8. Bute means 4 carbons. So C4H10. They all follow this general formula, CnH2n plus 2. So if you have, let's say, 5 carbons for pentane, if I have 5 here, it's gonna be 5 twice 5 plus 2. So it will be 5, or it will be C5H12. That's where that formula comes from. For hexane, N equals to 6, meaning you have 6 carbons. Okay, so it will be C6H26 plus 2. So it will be C6H14, the formula for hexane. Heptane, N equals to 7. You have 7 carbons. In that case, it will be C7. H twice of 7 is 14 plus 2 is 16. That's how we are getting the formula C7H16. Octane, N is 8. You have 8 carbons. That will be C8H28 plus 2. And that gives you this formula C8H18. 2 times 8 is 16 plus 2, 18. Non-N, you have 9 carbons. So N equals to 9. Non-N, 9 carbons. All these are alkanes. Alkanes, they are those compounds that follow the general formula CnH2n plus 2. That's what you are doing. So here you have 9 carbons. In that case, it will be C9H29 plus 2. That gives me C9H20. 2 times 9 is 18 plus 2 gives me 20. And then finally you have decane. Okay, so N equals to 10. You have 10 carbons, so it will be it will be what? C10, H twice of 10 plus 2. That gives you C10, H22. Now, here you are seeing the zigzag drawing. So we call it the zigzag, we call these drawings the zigzag drawings. If you're interested to do organic chemistry, you'll do a lot of these drawings. For example, let me pick a shorter one like propane. Propane has 3 carbons, so it's C3H twice of 3 plus 2, so it's C3H8. So we have 3 carbons connected with bonds, and then now we introduce the 8 hydrogens. H, 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 H. So you have fun drawing decane in that way. Just connect the carbons and populate the hydrogens. Keep in mind that each carbon must have no more than 4 bonds, no more than 4 lines.